Hi everyone. Continuing the model 2, I consider a square having 4 charges at the 4 corners of a square of side R. If I put a charge Q at exactly the center of the square, the question will ask you if the system in equilibrium, find the magnitude and the polarity of this charge. I already discussed the previous model for triangle. If the system in equilibrium, how many charges in the system? 5 charges, and the net force, any of the charges must be 0. This charge also 0, this charge is 0, this charge 0, this charge also this charge, because 5 charges in a system. If the system in equilibrium, net force on any of the charge must be 0. So I will consider this is as charge. I already said this is positive and repel. This is positive, repel. That's why the net force, and due to this charge, it will be go like this. And already with the net force I have derived, and the expression of this net charge is K Q square upon R square root 2 plus 1 by 2. Please go to the previous lectures. You can easily understand the things that how the net force will be derived like this. Now look at this scenario. Due to these 3 charges, 1, 2, 3, the net force will be like this. So what should be the nature of the charge? This charge must be negative, so that this will pull this direction, so that the net force on this charge will be 0. So this charge nature is negative. This is pretty clear. The charge nature is negative. If I consider the total distance, this is R, this is R. This total distance is root 2R. Half of the distance, can I say root 2R upon this half of the distance, this section, can I say as root 2 R by 2, and I can say R by root 2. Yes. From here to here the distance is R by 2. Net force on this charge 0 means this force and this force must be equal. So K Q square R square root 2 plus 1 by 2 equals to what? K Q upon R upon root 2 whole square must be. So K R square cancel, 1 Q cancel. So this is Q root 2 plus 1 by 2, and this is small q, and this R by root 2, and this is now 2. If this is Q goes this, now the scenario, this is Q by 2 root 2 plus 1 by 2. If I enter these things, this is Q root 2 upon 2 root 2 by 2 plus 1 by 4. A little design more way. This is root 2. Here I multiply root 2. Here I will multiply root 2. So this is 1 by root 2 plus 1 by 4. This is Q. And what is the polarity? This is the magnitude of this charge. This is the magnitude of this charge. And what is the polarity? What is the nature of the charge? And it is negative. Look at these questions, because one more time we'll repeat. Due to this charge, and this charge, the net force is like this, and this is KQ square upon R square root 2 plus 1 by 2. If you go to the previous videos, you can easily observe these things. And this force must be balanced by the force due to this charge. And I already said this charge must be what kind of nature? Negative, because this force is like this. If it is negative, it will pull like this. So net force on this charge must be 0. So, and the distance here to here is total distance root 2R, half of the distance root 2R upon 2. So we can easily get this is as R by root 2. So these two forces must be balanced. That's why the net force must be 0. Using this concept, we will get the Q value, and this is the magnitude of the charge, and this is the polarity, because this charge is negative in nature or negative in polarity, that we will call it. I hope the scenario is pretty clear. Based on the model 1, we discussed the net force on any of the charge. Based on the model 2, we discussed if the system in equilibrium for the symmetrical structures, find the nature and magnitude of the charge. That if you place this charge at the center. I hope the scenario is clear to all. Thank you everyone. Thank you for your watching.